Okay, I'm doing some AP Calculus midterm review. And if you'd like a copy of this, I got a link in the description for you so you can follow along. All right, let's get started. I'm going to erase all this here. And so we need to find h prime of x. And h prime of x, well, that is, if h of x is this, then we need to do that quotient rule, which I see it as f prime g minus g prime f all over g squared. And so it's really just filling in all those parts. What is f prime of negative 5 is negative 10. So the first thing I'm going to write is negative 10. And then g of negative 5 is 1. So negative 10 times 1. Minus g prime. G prime of negative 5 is negative 1/5. So I'm going to write negative 1/5. And f of that is 0. So we're going to write that is times 0 all over g squared. And g of negative 5 is 1, so we just put 1 squared. And I'm going to squeeze this all in here. Negative 10 times 1 is negative 10, minus, and we have negative 1/5 times 0, that's just 0. All over 1 squared, which is 1. And negative 10 minus 0 is negative 10, divided by 1, obviously, is negative 10. And there it is. We have C as our answer. All right, moving on to number 2. Find an equation of the tangent line of the graph of f of theta is tangent theta at the point of pi over 4, 1. Okay. So what I'm going to do is I'm going to write over here the f prime, or f of theta is tangent theta. So that means that f prime of theta, is secant squared theta. And we're going to take the f prime of pi over 4, which is secant of pi over 4, and the whole thing's squared right there. And so what is the secant of pi over 4? Well, we can have a little unit circle triangle right here, and this would be 1, and that'd be 1 when we have 45 degrees, which is pi over 4 in radians, and that means this is square root of 2. Secant is 1 over the cosine, and so what we're talking about is, well, cosine of pi over 4 is what, 1 over square root of 2. So the secant of pi over 4 is square root of 2 over 1. So that means it's going to be the square root of 2 over 1, but the whole thing squared, which is really just 2. So the f prime of pi over 4 is 2. Now, what does that mean, that f prime of pi over 4 is 2? That means the slope of the tangent. So when we're asked to find the, back here, we're asked to find, let's see, can I do this? We're asked to find the equation of the tangent line. What we can do is, since we have a point, and we have a slope, so let's use point slope form, which, if you may remember, is y minus y sub 1 equals that slope times x minus x sub 1. So that's y minus 1 equals that slope we just got, which is 2, times x minus x sub 1, which is pi over 4. We could add 1 to both sides. We have y equals 2 times quantity x minus pi over 4 plus 1. And we got a little bit more to go here. So that means we would have y is equal to 2x minus pi over 2 plus 1. Now, to get rid of the half. We can multiply everything by 2. What we get is 2y is equal to 4x minus pi plus 2. And so far, what we can see is it kind of looks like one of our choices here. I can see the 2y, and I could see 2y right here. It looks like that would be our only choice right there. And let's see if we can just kind of move things around here. We can have, well, to make everything look exactly like it, we could subtract 2y. So we have, and we could, so 0 equals 4x minus pi plus 2. Minus 2y. And then we would add pi, and we would subtract 2. So we would add pi and subtract 2. Whew, we need a lot of room for this one. And what we would have is pi minus 2 equals, these cancel, 4x minus 2y. And it looks like that option is B. So it looks like this right here is B. There's a lot of stuff right there. All right, let's move on to the next. Let me erase all this stuff. And let's look at number 3. Find the limit. Well, as x approaches -4. Well, the problem probably is right here. If I have -4 plus 4, that's 0. And then this is going to be, what, 16 minus 44 plus 28. And that's looking like that's probably 0 also. So what you got to do is you have to, I think you can factor the numerator. And I guess there's 2 ways to do this one. We can have, since we have 0 over 0, we can have that L'Hopital's rule where we take the derivative. That might be easier. I don't know what's easier. Well, I guess I'll finish that, and then there's another method I have. So if we take the L'Hopital's rule, that means we have to take the derivative of the numerator and the derivative of the denominator. So that means we have, what the derivative of the numerator is 2x, plus 11, and then derivative of the denominator is just 1. And then that would be 2 times -4 plus 11. And that is, what, -8 plus 11, which is 3. Okay, cool. And then there's another way to do this too. What you could do is you can factor the numerator, can't you? I think that's x plus 4 and x plus 7 divided by x plus 4. I would look for that. And then, boom, those cancel. And now you got -4 plus 7, which is still 3. I kind of like that. I don't know. Crossing the stuff out feels kind of good. Okay, so let's talk about number 4. So number 4, we're looking at as h goes to 0. So it has to approach 0. It can't be 0 because you can't divide by 0. But this looks like what f of x, f prime of x equals f of x plus h minus f of x all over h, something like that. So that means f of x is hiding right there, x to the third. So then what we're really looking at is what's f prime of x to the third, something like that. That is 3x squared. And that is a. So it's really just recognizing what is the function. Take the derivative of that. Super easy. Okay. For this one, I think that number 5 is different from number 3 because in number 3 you can just factor that easily, and I'm thinking you probably could factor that, but I can't remember what that factoring is for that numerator. So we're just going to use that L'Hopital's rule where you can take the derivative of the numerator, and so that would be what? Derivative of the numerator is 3x squared. Derivative of the denominator is just 1. All right, fine. So 3 times 2 for x, 2 squared. That's 3 times 4, which is 12. And that's E. For the next one, number 6, the limit as x approaches -7 from the right. Okay, so -7 plus 7 is 0. -7 plus 7, absolute value is 0. So you're not going to take derivatives of each of them. You'll end up with the same thing anyway. So let's, as it approaches from the right, that means like -6.9. So let's see what happens when you have -6.9. So maybe -6.9 substituted for x plus 7 over the absolute value of -6.9 plus 7. Well, that's 0.1, and this is the same, 0.1. So any number divided by itself is 1, so it's just 1. The next one, find this limit here. You plug in 0, and you're going to get what? That's going to be square root of 9 is 3 minus 3 over 0. It's going to be 0 over 0. So you're going to do that L'Hopital's rule once again, where you have to take the numerator, the derivative of the numerator. So remember, this is x plus 9 to the 1/2. So the derivative of this is going to be 1/2 times x plus 9 to the -1/2, and then minus 0. You know, who needs the minus 0, you know? And then divided by derivative of x, which is just 1. Well, that's the same thing as 1 over that 2. That 2 can go down here. And this can be x plus 9 to the 1/2. X plus 9 to the 1/2. Maybe we can tie it all together. And we could, well, as we say, oh, well, what's this going to be as it approaches 0? Well, as this approaches 0, that's just going to be square root of 9. So this is going to be 1 over 2 times, this is just the square root of 9, anything to the 1/2, you know. So that's 1 over 2 times square root of 9 is 3. So 1 over 2 times 3 is 1/6. Ooh. Okay. So it's none of these. Next, we have what the once again, we're going to probably have, as it goes to 0, that's 0. 3 times 0 is 0, plus sine of 0 is 0, divided by 0. So it's 0 over 0. L'Hopital's rule again. So we have the derivative of 3x is 3. The derivative of plus the derivative of sine is cosine x divided by 1, because derivative of x is 1. And now what happens when this goes to 0? Well, that's 3 plus cosine of 0 is 1. 3 over 1, right? So that's just 3. And so there you go. Oh, but wait. It's not 3 times 1. It's 3 plus 1. And that means I must have made a mistake. I paused for a moment thinking, what happened there? So 3 plus 1 is 4. Oh, almost fell into that one. Okay, next, number 9. The limit as, okay, you'd probably expect this to be, although you have to kind of check here, as it approaches -4. So what? This is 12 minus 40 minus 8? No way. Oh, let me write this down. So, oh no, 3 times 48, right? Yeah. So 48 minus 40 minus 8, yeah, that's 0. And then this is 16 minus 4 minus 12, that's also 0. So yeah, take the derivative of it. I'll erase this here. And we have derivative. So that'd be 6x. Or could you factor it? I think you can. I think it's begging to be factored. What would this be? So this has to be 3x, and that has to be x. And 8, 4, and 2. Yeah, 4 and 2. So it has to be positive, and that's negative. And then could you factor these? X is 3 and 4. So positive 4 and negative 3. Hey, the x plus 4's cancel. And that leaves you with 3x minus 2 over x minus 3. You probably could have done this with L'Hopital's rule too, I bet. So as it goes to 4, negative 4, so 3 times negative 4 minus 2 over negative 4 minus 3. What? That's negative 14 over negative 7, which is just 2. And I don't see 2 anywhere here. So I guess we go with none of these. Although I imagine something. Oh, wait. 2 is right there. Haha. 2 is right there. Yeah, could you use L'Hopital's rule with this? You probably could. Let's check it. If you have, what, 6x plus 10 over 2x plus 1, and it's negative 24 plus 10 over 2 times negative 4, negative 8, negative 7? So it's negative 14 over negative 7, which is still 2. Wonderful. L'Hopital's rule strikes again. At which rate is this discontinuous? Oh, it just wants to be factored, don't you? You do. You know you do. So let's see. This would be x 8, 4, 2. So minus 4 and positive 2. And there it is. It can't be continuous at x equals what? It can't be 2, or it can't be 0 down here. So that'd be negative 2 and positive 4. And so negative 2 and positive 4, whack. There you go. Okay, the next one is determine the value of c so that f of x is continuous on the entire real line when f of x is equal to this complicated thing right now. So x minus 2 when x is less than or equal to 5, and cx, so we got to find that c, right? So this whole thing is continuous when it's also greater than 5. So when it's continuous, that means it just kind of goes on through, and coming from the right side and the left side is going to have a limit, right? It's going to come to a certain point. So when it's less than or equal to, okay, that when it's greater than that. So this is coming from the left-hand side because that's when x is smaller than 0. And this is coming from the right-hand side when x is greater than 0, less than 5, and greater than 5. So on the left-hand side, we got our x minus 2. And our right-hand side, we have cx minus 3. And what is x? Well, x is that value. You know, we're testing for it to be 5. We want it to be 5 on coming to the left-hand side and to the right-hand side. So we want x to be 5. I'm going to rewrite this. So we have 5 minus 2 equals some number times 5. Oh, you know what? I should probably 5 times some number minus 3. So we're just solving this equation now. Oh, 5 minus 2, that's just 3, huh? That's just 3 equals 5c minus 3. If I add 3, I got 6 equals 5c. That means c is equal to 6/5. Well, there you go. That's what c has to be. It has to be 6/5. Okay. This one, which of the following statements is not true of this whole thing right here? Well, I think that it matters what can you put in for x. Well, obviously, if I put 7 in for x, that's going to cause a problem. Also, if I'm going to put negative 7 in for x, that would cause a problem. So what happens here? If I have something here, whatever this is, at negative 7 and at 7, we have an issue. In fact, nothing in here will exist. Because if it's 6, let's see, 6 squared is 36. That's if you have anything smaller than 7, absolute value of 7, inside this area, you're going to try to take the square root of a negative number. And, well, I mean, I guess we could use imaginary numbers, but I think they're talking about the real number system here. So, so what is not true? Well, it's not continuous throughout here. It's not working. So it has to be B right there. Okay. Find the limit as x approaches 1. Ooh, look at that. I mean, we're in trouble because this is going to be 5 over 0. You're not going to take the derivative of that because it's not one of those. It'd have to be 0 over 0 for you to use L'Hopital's rule. So this is just not going to work at all. X plus 1, x minus 1, nothing's going to cancel or nothing. It just doesn't exist. We can't do anything with this. This is none of these here. For this one, as x approaches negative infinity, what's going to happen to this? Limit. Well, these right here are going to be the same. This is, I mean, who cares about what happens over here, right? Who cares about this and over? It's way overpowered by this, what's happening here. And in fact, these are going to cancel right here. So it's really just 6/4. And 6/4 is equal to 3/2. Ooh, that's going to be C right there. All right. For the next question, number 15, find all vertical asymptotes of this graph. Well, it's a vertical asymptote. If it is 1, the denominator is 0. So when is the denominator 0? That's looking like it wants to be factored. 5, 2, and 5. Oh boy. Oh yeah, 2 and 5. Because it can be negative 5 and can be positive 2. And so the opposite of all that is what that makes 5. X could be 5 and x could be negative 2. So it has to be this one, A. A. Okay. If f of 2 is 3 and f prime of 2 is negative 1, find an equation of the tangent when x equals 2. Well, we did one like this. I mean, I think the second question was way harder than this, but it's similar, where we have the point slope form. Y minus y sub 1 equals the slope times x minus x sub 1. So that'd be y minus y sub 1, which is right here, 3. And then the slope is that derivative, which is negative 1. And this x minus that x sub 1, which is 2. And so when you have all this, it looks like we got a C for our answer right there. Number 17. F prime of x. Okay, find that where f of x is that. I mean, this one looks like it's going to be a breeze. I mean, this is easy. 4 times 3 is 12. X, drop it down to 1 less. And the exponent, minus 18, x to the second, plus 3. Oh boy, that was too easy. B. Find f prime of this. Okay, so it looks like a quotient rule that we're going to have to apply to this. All right, so f prime. So this would be what? F prime g minus g prime f all over g squared. And that was certainly my initial thinking, but we could split this up to where this x squared over the square root of x, which is x to the 1/2, minus 4x over that same x to the 1/2. And what have we got here? This is 2 minus that. So 2 minus a half is 3 halves. So this is x to the 3 halves minus, what, this is 1 minus a half. So that would be minus 4. 1 minus a half is 1 half, so 4 to the 1 half. And so now we're going to take the derivative of this, of each one. Let's put a little room over here. So f prime of x, or f prime of x would be what? That's we take what's in front, 3 halves x, and then minus 1, so that's 3 halves x to the just 1 half, because 3 halves minus 1 is 1 half, minus 1 half, right? So that's 1 half times 4. Oh, did I forget an x? I forgot an x right there. Right here. 1 half times 4, which is 2, x, and then 1 half minus 1 is negative 1 half. And we're almost there. So let's clean this up a little bit. We have 3 times x to the 1 half is the square root of x over 2 minus 2 over the square root of x. And so if we, if we're going to try to make this look like anything, it certainly looks like it's going to be a, right? So let's see what it takes to make it look like a. Well, if you multiply by the square root of x, so let me erase this little bit here. If you multiply this by the square root of x, what do you have? That's 3x, because that'd be 3x in the numerator, over 2 times the square root of x. And if you multiply both of these by 2, that would be equal to 4 over 2 times the square root of x. Oops, that's just minus right there. And so what we'll have is 3x minus 4 over 2 times the square root of x, and square root of x is x to the 1 half. So it'd be 3x minus 4 over 2 times 1 x. Oops. X to the 1 half. And I believe that's what we have for, exactly what we have for a. It's just kind of awkward how the formatting they have of it. So there's a bunch of algebra there. I think the calculus really just stops at this point here, and then the rest down here is just algebra. Okay, let's see what we got here. Oh, I wonder. Okay. So that was 18. Number 19, find dy dx. Y is equal to this plus, oh boy, it's a huge long thing. But, it's easy because we don't have to do any product rules or quotient rules or anything. So what we have is y prime. Oops. So y prime is equal to what? 5 times the derivative of cosine is negative sine x, minus 3 times the derivative of sine is cosine x, and then derivative of 4x is just 4. So it looks like the closest thing we have, oh, it's right here. It's b. Right? Because what we could do is that negative can go in front, and then we have that negative can go in front, and now we have 5. And then the rest is all exactly the same. So 5 sine x minus 3 times cosine x plus 4. Number 20, find an equation for the tangent line to the graph of this thing at the point where x equals 1. Well, we got to find what is the slope of that tangent line. So f prime of x is equal to, what, 4x minus 2. Okay, at where x is 1, so f prime of 1 is 4 times 1 minus 2, which is 2, I believe. And so now keep in mind, we're looking at that classic point slope form y minus y sub 1 equals m times x minus x sub 1. And we have x sub 1, that's just 1. It's right over, I'll squeeze this in, it's right here, x is 1. So what we need to know is what is f of just 1, so we can get the y. That's 2 times 1 squared minus 2 times 1 plus 3. So that's equal to what? 2 minus 2 plus 3. Oh, it looks like it's just 3. So we have the point 1 comma 3, and that's what we're going to put into our point slope form. So that will be what y minus 3 equals, that slope was 2, x minus x sub 1, which is 1. It looks like we have that here, but I don't see that anywhere at all. So let's massage this a little bit. Y equals 2 times the quantity x minus 1 plus 3. That's 2x minus 2 plus 3, and that is 1. So y equals 2x plus 1, D. Let's see here. The position function for an object is that, where s is measured in feet and t is measured in seconds. Find the velocity. Well, the velocity is the derivative of that position function. So let's take the derivative of that. That would be 12t plus 240. And then t is 2, so it's 12 times 2 plus 240, which is 24 plus 240, which is 264. And it looks like that's C. And here's another where number 22, the velocity function for an object is given by s prime of t. Okay, it's measured in feet and t is measured in seconds. Okay, what's the instantaneous velocity when t is equal to 3? Well, all we have to do is just plug 3 into that. So instantaneous velocity, yeah, you might as well just call it velocity. And so that's negative 15 times 3 squared plus 8. That's negative 15 times 9 plus 8. And let's see, 15 times 9. I actually don't know what that is. 135. Negative 135 plus 8. That's negative 127. And there you go, D. Number 23, a particle moves along a straight line with position function this. State when the particle is moving in a negative direction on the interval, the closed interval from 0 to 10. So it's moving in a negative direction when velocity is negative. So velocity is the derivative of that, which is what, 2t minus 8. Okay. So when is this going to be negative? So first off, when is 2t minus 8 equal to 0? Add 8. 2t is equal to 8. T must be 4. So when t is 4, let's see, when t is smaller than 4, when t is smaller than 4, what, like 3, that's going to be negative, right? Because it's 6 minus 8 is negative. So that means that over here, it's going to be negative. How about, so we have this, and we have this. What about when t is like 5 to 10, like 6? What if t were 6? Well, 2 times 6 is 12. 12 minus 8 is 4, and that's positive. And that would be a positive direction. So it's definitely not this one. It's just d. It's just that interval, open interval from 0 to 4. Okay. Differentiate this. Well, that certainly looks like a quotient rule to me. And I don't know, I just like to write what? F prime g minus g prime f all over g squared. So f prime, that is 5 times g, which is x squared plus 1, minus g prime, which is 2x, times f, which is 5x, all over g squared, which is x squared plus 1, and the whole thing, all of that has to be squared. Maybe when I'm looking at all this, b is looking like that's the answer right off the bat, because it's the only one that has the same denominator, right? But I'll play along here. What? This is going to be 5, distributing the 5x squared plus 5 minus 10x squared all over x squared plus 1, and that whole thing is squared. And so combining like terms, that's negative 5x squared plus 5 over x squared plus 1 squared. And you factor out the 5, the negative, and the 5. Right? If you factor out the negative and the 5, then that is just x squared minus 1 over x squared plus 1 squared. I'm thinking about, and then I could just switch. If I just switch the order of these, I have this right here, and so that's it right there. Okay, differentiate this. And we got to remember, what's the derivative of cotangent? Yeah, cosecant. So this would be 3x squared plus 3 times cosecant of x. Oh, well, it's going to be b. Isn't that right? Oh, classic trap I fell into, isn't it? It's not plus. It's the derivative of cotangent is negative cosecant, right? So that negative cosecant is has to be put right there on the front, right there, right over there. So it's negative cosecant, and that makes it c, because I almost got b. Almost. Find f prime of x for f of x is that. Big old chain rule, huh? So that would be equal to 7 times the inside to x squared plus 5 times to the 6, and then times the derivative of the inside, which is times 4x. Okay. Can I just do that right there? Well, I think we got kind of lucky here. 7 times 4, if we just multiply those two together, that's 28x, and then times 2x squared plus 5, all taken to the 6th power, which looks like it's d right there. Find the derivative of this, secant. Well, the derivative of secant is secant tangent, I believe. So f, oh no, where'd it go? Right here. Here it is. So f prime of x would be derivative of secant is secant of x over 2 tangent of x over 2. And then we have times a half, right? Because as we take the derivative of that, and then you have to take the derivative of this right here, which is 1/2 times x. Well, the derivative of x is just 1, and so you still have that 1/2 in front. So it's times 1/2, because that's the derivative of the inside. And I don't think I can match this up with anything here. Man, it just wants to be this, huh? But that's not the case. It's going to end up super close on that. Okay, so let's do number 28. So this one's kind of tricky, where you have y prime is going to be derivative of the outside, so that's 2 sine t, but then the derivative of sine is cosine t, minus, take that 2 again, 2 cosine t, times the derivative of cosine, which is negative sine t. Maybe I'll put this in parentheses here. Negative sine t. And what you get is 2 sine t times cosine t plus cosine t sine t. 2 right there. And then it looks like we have something like terms, because it's 2, well, I mean, forget the 2. Sine t plus times cosine t, and cosine t times sine t. That's like the commutative property, right? They're just the same thing. So it's 2 of these plus 2 more of these means you have 4 of these. So it's going to be 4 sine t cosine t. And it looks like we don't see that at all here. I certainly don't. Okay. Next one, 29, f double prime of x. Find f double prime of x if f of x is equal to this. So we have to take the derivative of this twice. Okay. So that means it's going to be what? Let me go up here a little bit. So f prime of x is going to be derivative of that whole thing is going to be what? Derivative of sine is cosine x squared. And then the derivative of that inside of x squared is 2x. And so this is going to be the old f prime g plus g prime f. F prime, that's going to be what? Derivative of cosine is negative sine of x squared times the derivative of that inside right there, which is 2x. So it's f prime g times 2x, that's the g, plus g prime 2 times f, which is times the cosine of x squared. Boom, boom. And let's see, what do we have here? We have, what, 4? Negative 4 sine squared x squared plus 2 cosine x squared. And where do we stand with this so far? Well, a little wonky here, but we could factor out a 2. Factor out a 2, so it's and let's switch the position here. So let's bring this over here. So it's cosine of x squared, and then minus 2 sine squared x squared, sine squared x squared. And that's exactly where I want it to be. Because what I forgot to do is I forgot to put that's x squared and that's x squared. So what this ends up being is a. Wow. That was quite the pull right there. Find dy dx for that whole thing right there. Let's see. Let me pull this over. Let me take a copy of this and bring it over here so I have more room to work. So dy dx, well, this is 4x dx plus product rule f prime g plus g prime, which is dy dx, fx, plus 6y dy dx equals 0. Okay, let's go with, so solving for dy dx, let's subtract 4x minus y minus 4x minus y. So what is this? We have dy dx, x plus 6y dy dx equals negative 4x minus y. And factor out dy dx. So you have x plus 6y equals negative 4x minus y. Divide by x plus 6y. Divide by x plus 6y. And hopefully we have this as one of our potential answers. Yeah, I see it right there in B. Because if I were to factor out a negative, if I factor out a negative, that'd be 4x plus y over x plus 6y. And so it's B. Okay, we have this one, 31. Find dy dx, then evaluate the derivative at the point 0, 2. So we need this. I'll go over here, and I will copy this so I have more room. Dy dx. Let's go. So this is going to be 10x minus 3 times, here's the product rule, f prime g plus g prime, and then that's dy dx, and then f prime g plus g prime f, plus 1 times dy dx equals 0. Derivative of 2 is 0. And then let's do 10x minus 3y plus 3 x dy dx plus dy dx equals 0. So we need to subtract 10x and add 3y, subtract 10x and add 3y. So that's 3x dy dx plus dy dx equals, maybe I should switch this. So 3y, y minus 10x, and then this is dy dx, factoring out the dy dx is 3x plus 1 equals 3y minus 10x, and then you have to divide by 3x plus 1. And it looks like this will be our final answer. And I'm thinking, oh, I forgot. That was minus 3y, right? Oh, yeah, this was minus 3y. So that means it would be, plus 3y. Yeah, that looks, but I see this needed to be minus 3x right here, right? Because if I distribute that, that's minus, so that's minus right there. And then that makes this minus, minus, minus. Now let's look at this. And do we have, and then 0, 2. 0, 2 is our 0. So it's 0, 2, which this is the x and this is the y. So that's 3 times 2. Oops, I'm thinking ahead. 3 times 2 minus 10 times 0 over negative 3 times 0 plus 1. And so that's 6 over 1, which is just 6. And it looks like, hey, that's 6. That's right here. That's D. Right there. Okay. Let's look at number 32. The volume of a cube is changing at the rate of 18 cubic centimeters per second. How fast is the edge of the cube expanding when the edge is 3 centimeters? I know that the volume of a cube is the side cubed. So dv dt is going to be 3 times s squared. Okay, and that dv dt is 18. And now we need to go over here. I need to erase some of this stuff. It just went too far in this whole thing here. And so let me put this all together here. And what we need to do is we need to see that we have the dv/dt is definitely that. And so dv/dt is also 18. So what we can say then is instead of dv/dt, we have we have 18 is equal to the 3s squared. Oh, and that is ds dt. Or what I should say is the side is x, isn't it? So let me erase this here and say I have 3x squared dx dt, right? Because we're trying to find how fast that edge is expanding, and the x is the edge. So we have 18 is equal to that, and x is 3 when the edge is 3. So it's 3 times 3 squared dx dt, or ds dt, whatever it is, and s for side. And so that's 18 is equal to, what, 3 times 9 is 27? Dx dt, or ds dt. Maybe I should have done it ds. Anyway, if I divide by 27, these cancel. Divide this by 27. Oops. 27, and divide these both by 9. That's 2/3 is dx dt, and that's a. Okay. Something similar. A spherical balloon is inflated at a rate of 16 cubic feet per minute. How fast is the radius balloon changing at the instant the radius is 2 feet? Remember that volume is 4/3 pi r cubed. Ooh, that's just asking to be turned into a derivative right there. So that volume, cubic feet. Cubic feet is volume per minute, so that's dv dt. So dv dt is 16 cubic feet per minute, and we're trying to find out how fast is the radius of the balloon changing. So what's that rate? So what is dr dt with respect to time? And when the radius is at 2 feet. Okay, so if the volume is given to us as 4/3 pi r cubed, and we take the volume, the derivative of that, that's 3 times 4/3 is 4 pi r squared. Okay, so that's the derivative of that. Oh, and with respect to the radius, so with respect to time, so the derivative of radius with respect to time. And then we're given it as dv dt. Instead of v prime, I should have called it dv with respect to time. And that dv dt was originally set as 16. And so this 4 pi r squared dr dt. Now here comes the algebra. Divide by 4 pi r squared. Divide by 4 pi r squared. And I want to say the radius is given us as 2. So that's 16 over 4 times pi times 2 squared, which is 16 over 16 pi equals dr dt. And so that means that these cancel. It's 1 over pi is dr dt. And so is that any of our choices now? Yeah, it's right here, 1 over pi. 1 over pi. All right. I gotta erase this because it clearly went way over my space here. Okay. Number 34 is if f of x is equal to x to the third, that thing, and g of x is the inverse of that, then what's g prime of 5? So what we have is in this, I'm going to copy this here so I have more room. Oops, this is the copy one. And bringing this over here. So if we have the g prime, so in this statement, g of x is equal to f, the inverse of x. What that means is as we have f of x, we have the f and then the x and y, and then the g, the x is here and the y is here. So when we have what is it? F of x, y. So when we have g, we have g of x, which is this. So that means it's going to be the y here. And so when we have our f of x function, we then, instead of f of x, we can write 5, which is equal to x to the third minus 2x to the second plus 3 x minus 1. And we need to figure out, well, what will work here? What will work for x? Now, I've looked up, hey, how do you solve these cubics and such? And it's really just a guess and check kind of thing. You guess 1. Will 1 work? Well, 1 to the third minus 2 times 1 plus 3 times 1 minus 1. That's 1 minus 2 plus 3 minus 1. Is that equal to 5? Well, it's negative 1 plus 3 minus 1. That's just 3. So that's not equal. And then, it's going to be, you could choose the negatives or whatever, but having looked at this already, it's 2. 2 to the third minus 2 times 2 squared plus 3 times 2 minus 1. This is going to be 8 minus 8 plus 6 minus 1. These cancel, and so that's 5 equals 5. So, yes, that is 2. So, finally, to copy the copy here in g prime of 5, well, that's the inverse of the f of x function, which means it's 1 over f of x and f prime of x, right? And specifically, f prime of 2, because, if the y is 5, the x must be 2. So we have here prime of 2. Well, that's 1 over, that ends up being what? The derivative of this function, what, f prime of x is what, 3x squared minus 4x plus 3. So it's 1 over 3 times 2 squared minus 4 times 2 plus 3. Which is 1 over, what, 12 minus 8 plus 3? Yeah, so it's 1 over 7. And that looks like what we have for this. Whew, what a beast. That was a beast right there. Where was it? 1 over 7, right here. Boom. All right. Let's look at this one here. The sides of the rectangle. Ooh, this has got to be made smaller here. The size of a rectangle above increase in such a way that dz dt is 1, dx dt equals 3, dy dt at the instant when x equals 4 and y equals 3. What is the value of dx dt? Well, first off, if x is 4 and y is equal to 5, then, ooh, look at that. That's rare that it would be the case right there. In fact, I believe that there was, oh, y equals 3. Yeah, I was going to say, wow, that would be bad. Because usually it's a 3, 4, 5, right? 3, 4, 5 triangle, which is wonderful. And so this follows the Pythagorean theorem. And if it follows the Pythagorean theorem, then that means that x squared plus y squared equals z squared. Let's take the derivative of this with respect to t, and that would be 2x dx dt plus 2y dy dt equals 2z dz dt. And what is the value of dx dt? Okay. Well, we need a little bit more room here. I'm going to erase all this stuff. And I'm going to get rid of this here. And that right there. And I'm going to bring this over because I need a little bit more room here. And I'm going to zoom in here. How about we just divide by 2, right? If I divide by 2, divide by 2, divide by 2, I then have x dx dt plus y dy dt equals z dz dt. Okay, so that's cleaning things up a little bit. And we need to know the value of dx dt, so we're trying to solve for that right there. Now, back in the problem here, we know that x is 4, y is 3, z is 5. So x is 4 dx dt, y is 3 dy dt, and z is 5 dz dt. And we're trying to solve for dx dt. Now, something that we're also told is right here, this is an important piece of information. Dx dt is 3 dy dt, so we have to substitute that. So dx dt, so 4 dx dt is 3 dy dt. And then we have plus 3 dy dt equals 5 dz dt. Okay, so we can multiply this. So this is 12 dy dt, and that makes it kind of nice because now we can factor out a dy dt. And so that ends up being dy dt times 15, right? Because 12 plus 3 is 15. Oops. 15 equals 5 dz dt. Oops. And now we're ready to walk through the door because we're looking for, and dz dt is 1. So dz dt, I forgot to say earlier in the problem, is 1. That says it. So that's times 1, right? So that means that this is equal to just 5. Okay, and then so dy dt, we divide by 15. 5 divided by 15 is 1/3, so dy dt is equal to 1/3. Whew, another beefy problem there. So that is 1/3 A. All right. What else we got? Number 36. At x equals 2, the function defined by this thing is, well, is it undefined at x equals 2? Oh boy, that's kind of tough because it's x squared at that point. So at 2, this is 4, and this is 4. So it looks like it's going to be continuous because when it's 2, it's going to be arriving at 4 and from the left side and from the right side. So it looks like it's going to be continuous. Okay, but if we have a little graph of that, we would have boom, boom, 1, 2, x squared when it's less than, so it's like this, and 2x, which looks like this. And so it's going to have a little node right here. So it's not going to be differentiable at that point. But it's going to be continuous. It's going to go through. But those little corners, if you remember, it's not differentiable. Here, the velocity of a particle is given by this function. Let's see here. By the function that. What is the acceleration of the particle at time set? So velocity. So we have to take the derivative of this. And so the v prime of t is 3t squared plus cosine t. And then when t is 2 pi. So let's see, 3 t squared, so 3 2 pi squared plus cosine of 2 pi. I think cosine of 2 pi, that's just 1. And then this is 4 times 3 is 12 pi plus 1. And and it's squared, right? Because that's a little squared right there. So 12 pi squared. And yeah, there it is. A. Super. Whew, 40 questions almost done here. Ooh, yeah, the graphs right here. The graph of the derivative of f is shown in the figure above. Okay, which of the following could be the graph of just f? Okay, so this is, remember, this is the derivative here. So this is the slope of the curve. And if I look at well, if we look, let me bring this up here like this, and if I look at the curve, boom, if this were this, the at -2, the what is the slope? The yeah, here the slope is negative, so that means it's negative here, right? The slope is negative. So that means it's going down like this. And then here the slope is 0. So that means it's going to round out. A 0 slope is a horizontal line. And then here the slope is positive, all in this area. So that means it's going to go up like this. And then it hits its maximum right there. And then now at +2, what's happening? The slope again is 0. So it's 0. It's going horizontal at that point. And so that means it's changing right there. And the slope is still positive over here. So it's still positive, but then it hits 0. So it's positive, and it's not as positive. See, it's like the slope is slowly going closer to 0 right there. And once it's 0, it has to go down into the negative. So it's going back down into the negatives right there. So this is what we're looking for. We're looking for something that has a dip at -2 and a max at +2. And so, here, I gotta do this right here. So it has a dip right here at -2, a dip at -2, dip at -2. Ooh, just the opposite right there. And then max at +2. So, ooh, that's pretty close right there. But it's going to be at 2, like exactly 2 at -2. So it's going to be A. Number 39. The normal line to the curve of this f of x at slope has a slope of what? well, the normal is going to be perpendicular, right? So so let's I mean, we're talking about slope right now, so let's find the derivative. So f prime of x is going to be what, 1/2 times 8 minus x squared to the negative 1/2, and then you have to multiply by negative 2x, or I'm sorry, yeah, negative 2x times negative 2x. And so what I see right here is it looks like that 2 and that will cancel each other out. And what we're left with, let's clean this up a little bit. You have still the negative and the x on the top. And on the bottom, you have a negative, you can take the square root of 8 minus x squared because that's a negative exponent right there. Let's plug in our 2 and negative 2, right? Or just the 2. So f prime of x is that. So f prime of negative 2, that's all we need, is the x right there, equals negative 2 over the square root of 8 minus negative 2 squared. So that's 2 over the square root of 8 minus 4, which is 4, which is 2 over 2. Ooh, that's just 1. Wow, all that work for just 1, the number 1, huh? And whew, our last one here, the last question. If x squared plus y squared equals 25, what is the second derivative, y and over dx squared? Let me do this here. And it's going to take a little bit of work. The first part's pretty easy. It's just take the derivative of that. What it's going to be 2x plus 2y equals dy dx, right? So this would be dx over dx, and this is dy over dx. Equals 25. This derivative of 25 is 0. Okay, so let's just solve for dy dx. So minus 2x minus 2x, 2y dy dx is equal to negative 2x. Divide by 2y, and divide this by 2y, and dy dx is equal to negative 2x over 2y. Oh, these cancel, so it's negative x over y, right? So that's good so far. But we need the second derivative, right? So we need to take the derivative of that, which is the quotient rule, which is what, that's going to be f prime g minus g prime f over g squared. So f prime is, so the second derivative is f prime, which is negative 1 times g, which is y, minus g prime, which is 1, but it's a dy dx, times negative x, all over g squared, which is y squared. All right, this is a little bit of a mess, so let's clean this up. This would be negative y. Negative times negative is positive. X dy dx all over y squared. And we've got to make sure that we have that right. And we can use a little bit of what we already know. We already know that dy dx is that. So we can substitute what, negative y plus x times negative x over y, that's dy dx, the original one, over y squared. Let's bring this up a little bit. Right there. And so that means we have negative y plus, minus, right? Minus x squared. Minus x squared over y, right? Over y. Oh, over y squared. Y squared. Now, at this point, this looks nothing like any of our options. Let me bring down our options here. Right here. It looks like nothing. So we got to do the sneaky trick right now. And we need to multiply all of this by y over y. And what does that do? That's negative y squared. The y's cancel out the next one, minus x squared over y times y squared is y to the third. And it looks like we would have to factor out the negative x, or just the negative. So if you have that, y squared plus x squared over y to the third, and y squared plus x squared, well, all the way in the beginning here, we're told that y squared plus x squared is equal to 25. And so you can put that in there as equal to negative 25 over y to the third, holy cow, which is e. Wow. So that's it. It's crazy. We did it. All 40 questions. Midterm review. If you're studying for midterm, I wish you good luck, and I hope this was helpful. Bye.